Let us now study about spectral lines emitted by a hydrogen gas. We know that in a hydrogenic atom, when some energy is supplied to the electron, it will be excited to the higher energy level, and after the excitation lifetime, it drops back to the ground state. Same phenomena let's discuss over here. Say if this is the electron orbit configuration for a hydrogen atom. Say this n equals to 1, 2, 3 and 4, and from n equals to 1 state, a photon is supplied to the electron, and say the photon energy is 12.75 electron volt, which we already discussed is the energy difference of n equals to 1 to 4. So as soon as the electron will absorb the photon, it will make a transition to n equals to 4. And here n equals to 1, 2, 3 are vacant. So after the lifetime of excitation, which is of the order of 10 to the power minus 8 seconds, this electron will have a tendency to drop back or de-excite to any of the lower states. As all these three states 1, 2 and 3 are more stable compared to n equals to 4 because of lesser energy, it can make a transition either to n equals to 3 or to n equals to 2 or to n equals to 1. If it makes a transition to 1, it will emit a photon of 12.75 electron volt. If it will make a transition to 2, the photon of energy difference 4 to 2 is emitted, and a photon of energy difference 4 to 3 is emitted if it drops back to 3. Say it drops back to n equals to 3, then again 2 and 1 are stable states. So within the period of lifetime of excitation, as soon as it gets over, it will either make a transition to 2 or to 1 because these two states are more stable compared to n equals to 3. And the electron which is there in n equals to 2, either it comes through n equals to 3 or directly from 4. Ultimately, it will drop back to n equals to 1. So we can state whenever an electron in a hydrogenic gas is excited to nth energy level, ultimately it will drop back to the ground state because that is the most stable state. So here we can say there are various possibilities of photons emitted when it drops from n equals to 4 to n equal to 1. If we talk about the possible paths of electron for de-excitation, here we can see from n equals to 4, the first path is step by step, it is coming from 4 to 3, 3 to 2 and then 2 to 1. In this situation we can see it will emit 3 photons in the 3 successive transitions. So here we can say 3 photons are emitted. Say if it is following a path from 4 to 3 and directly from 3 to 1, then in this situation we can see 2 photons will be emitted in the process. And say if it is following 4 to 2, then 2 to 1, then also 2 photons will be emitted in the process. If it is directly transiting from 4 to 1, then only 1 photon will be emitted in the process. As we know, in each transition, 1 photon of energy equal to the energy difference of the two corresponding levels will be emitted. If the photons which are emitted corresponding to each transitions are passed through a spectrometer, in the spectrometer corresponding to each wavelength of a photon or electromagnetic radiation, a spectral line is plotted. So we are going to discuss about the spectral lines emitted by a hydrogen gas or hydrogenic atoms, which depend on the number of states to which the electron is excited. So here we can say if an electron is excited to nth energy level, then total number of possible spectral lines emitted during its de-excitation are total number of lines here we can write NC2, we can use combinations, that will be n into n minus 1 by 2, because corresponding to every two energy levels, corresponding to each pair of energy levels, here we can say one photon is emitted. So corresponding to fourth energy level, total number of photons emitted will be 4C2, that will be 6. In this situation also you can see 1, 2, 3, and this we already counted, so this will be the fourth one. This 2 to 1 we already counted, this will be the fifth one, and this is the sixth photon which will be emitted. So as if there are several atoms, in any atom any path can be followed. So in total number of spectral lines or type of photons which are emitted can be taken as n multiplied by n minus 1 by 2.